We got a letter from a flight instructor recently, and I've got it right in front of me, and I'm going to read it to you real quick, and then we're going to talk to him. It says, Mark, I have been listening to your show for the last month or so, and I wanted to share my professional opinion on one of your recent topics. I am a professional pilot and certified flight instructor. I run my own business at a smaller airport in the Midwest. In my previous 6 years teaching others how to fly, I can absolutely verify that your recent guest's claims about the gyroscopic properties of the aircraft's altitude indicator are correct. Robert did a great job in describing how it works, and he was spot on. Never in any textbook or other literature have I read anything about correcting for a curved Earth. We rely on those instruments in bad weather and literally risk our lives trusting that the instruments will not deviate from straight and level ever. That's in all caps. That alone was proof enough to a well-educated pilot to question everything I thought I knew, and am now very much convinced that we have some serious examining to do regarding the world in which we live. I've been recently trying to work out the math regarding the long-haul flights and trying to determine just how exactly they are fudging the numbers. I will pass along any info should I make any breakthroughs, and I hope he does. So with that, we're going to welcome John Walter to the show.
Hey, guys.
Hey, how's it going, man?
What's going on? Doing good.
So you are. Let's get the details out of the way. Let's get your background stuff. So you are currently, and if you don't want to mention exactly where you are, that's totally fine. Our last guest, as you know, has been going the other way and making himself the opposite of anonymous. So,
yeah,
and that would be Navy missile instructor Sean McCrary. So you're a flight instructor out of where?
We're in Iowa, and we're northeast Iowa, and I've got a little business I run here teaching people how to fly. We do all sorts of different commercial aircraft activities, but our primary business is teaching people how to fly, and that's what I've been doing for the last 5 or 6 years.
Cool.
And yeah, so
what type of planes?
Just small single and twin piston engine aircraft. Basically, teach you from nothing all the way up through commercial.
Got it.
So yeah.
Got it. And how do you? You'll have to forgive me because even though my brother-in-law flies, I do not know. How do you become a certified flight instructor?
To become an instructor, so there's various levels of ratings you have to get through. Basically, you have to become a commercial pilot first, and then at that point, you can go on to do the additional training to get your flight instructor certificate. And then there's varying levels of instructor abilities that you can, different levels you can achieve. So I'm a certified for single engine and multi-engine and instrument aircraft, which is basically all 3 ratings you can get as a flight instructor. And I'm also an advanced ground instructor. So,
so can you kind of break it down for us? Your comparison to how the gyro works in the plane.
Yeah.
And
yeah.
What's going on in your head?
Sure. So, fundamental. The primary instrument that we use as pilots when we're flying our aircraft, and it doesn't matter whether you're flying a small single engine or a large airliner, it makes no difference. The primary instrument we all use is called the attitude indicator. And I know, just with a little bit of research that, subs have the same thing, because it's basically what it does. It creates an artificial horizon, which is another nickname for it. And basically, it tells you, using a gyro, an internal gyro, it keeps itself straight and level, and it tells you which way is up, which way is down, and which is very important, obviously, when you're flying through the sky, and more important for like the airliners when they're flying through adverse weather, when they're flying through the bad weather, they need to know when they can't see the ground where the ground is, which way to go to fly. So that's the use of the instrument, and it operates using a gyro. Which you set, when you start the aircraft up, when you're sitting level on the ground, flat and level, you set that instrument and it spools up. You make any adjustments you need to get it calibrated so it's straight and level, and it stays there for the duration of the flight, and it does not deviate, does not wander whatsoever.
Yeah. So basically, if I can help, and feel free to break it down even further than what I'm going to do. So basically, the gyro is just like a giant 3-dimensional bubble level that you set when you're on the ground. So when the plane, what you're doing is you're assuming that where your plane is sitting is flat and level, and you set a level to say, you know what, show me where flat and level is, no matter what happens in the air. Show me what flat and level is on the ground.
Exactly.
And I don't know much about the plane ones. Do the plane ones spin up with RPMs like they do on ships, or are they kind of a little bit different?
Well, they're either operated with a vacuum system or an electrical system. Either they're an electrically powered gyro or a vacuum powered gyro. But either way, yes, the aircraft has to be the engine has to be running, which is providing that source of power. So
got it.
Yep.
Got it.
In fact, on most aircraft, a lot of aircraft, they actually have two. They have one vacuum powered and one electrical, so that you have redundant systems. So if one goes down, you're still good to go. So anyway.
You know what, though? Most people don't use gyroscopes like you guys would for that purpose.
Sure.
But I know sometimes they'll put them in like image stabilization equipment, like binoculars.
Oh, yeah.
And it's amazing when you hit that button and you feel that little, I guess, it almost feels magnetic because of the force of the gyroscope. Yeah. And then it's perfectly still, like all the shakiness goes away. So
Yep.
It's amazing what it must do, I guess, for navigation and such. I mean, the way it works.
Oh, it's incredibly accurate. I mean, when we're doing pitch changes up and down, I mean, your standard deviations, bank angles are, if you're flying in the clouds or like airliners, you're using less than 10 degrees of bank and typically, on average, less than 10 degrees of pitch. I mean, we're measuring a few degrees of pitch change, so it's incredibly accurate on a small little 3-inch display, that's just using a gyro. I mean,
can I ask one more question to that?
Yeah.
Is that when they say, like, when you fly by wire or you're using assistance with that? Is it paired up to the gyroscope for that reason?
The fly-by-wire is referencing how you are actually making use of the flight controls. Mm-hmm. So in our small aircraft, we're pushing and pulling on the yoke, which is moving cables and pulleys that go out to the control surfaces.
Okay.
Fly-by-wire just means you're electronically sending the signals out, but it's still the autopilots and all the systems, the automation systems on the aircraft are all linked up to that to those instruments and still rely on that instrument control. Absolutely correct. So.
Well, let me ask you this then. Because you've been flying for a number of years, can you, because lots of people have emailed me. It says, well, wouldn't the pilots know? Wouldn't the pilots know? Mike, I get that parroted to me all the time. It's like, how do the pilots not notice this? And I was going, well, because it's not a negative, with positive reinforcement versus negative reinforcement. Since nothing goes wrong and they take off from one point and land at the other point, and nothing goes wrong and the gyro does what it's doing, it stays level and there's no weirdness happening. Why would they question it? Do you kind of follow it? Well, let me ask, why didn't you question it?
Right. Well, yeah, it's a great question, and that's the question I'm still asking myself. But I don't have the exact answer to that. I don't know why we haven't picked up on it, but I think one of the things that has to do with is the fact that from primary training, I mean, flying an airplane isn't as simple as like you see in the movies. You jump in, push a button, and off it goes. You're obviously doing quite a few things, quite a few tasks before you take off, and the pilot's workload is very high as far as determining where they're going to go, trying to navigate, communicating, make sure the aircraft's safe and operating the system. So I don't know if it's just a task saturation thing where we just, you're too busy focused, you're kind of looking down, it's like you're staring down at the desk, you're not looking up and seeing the big picture.
Yeah.
But
that and the gyro works. It works. It gets you there. Nothing.
Right. Exactly. And if it works, if there's nothing to prompt you to say, well, why didn't it work this time, or why isn't it work? I mean, if the math equation always comes out to be the correct answer, you don't care how you solved it. You just care that you got the answer right.
Yeah.
You know what I'm saying?
Yeah.
Yeah. So I know a lot of kids in high school that's how they pass tests. I don't care how I figured it. I just know I got the right answer. Done.
Yeah. Yeah. As long as you take off in Dallas and land in New York, who cares? Who cares?
Yeah.
Who cares how you got there?
Well, and one misconception I think with people in the aircraft on the airline side of things, especially when you're traveling a long distance like that. I mean, yes, we are flying a long distance, and yes, we know from where we're starting where we're going. But generally, as a pilot, you're not thinking like, okay, it's 855 miles to go to get to LAX. It's like, okay, now we're over, Atlanta. Now we're over. You're kind of working in small chunks. And so you never really grasp the big picture. I mean, you do, but you don't. Does that make sense?
Yeah. Yeah.
So,
yeah, it does. Wow. So, in your mind, was there so you were listening to some of this stuff. So you listened to the Flat Earth Clues, but did it didn't click into your head until they were describing the mechanics in terms of the gyro in this case?
Well, no, actually, what sold me on the whole thing right off the bat was the clues, and specifically the long haul flight, because it had to do with airplanes, and that's what caught my attention. I thought, okay, something I think I know something about, and then all of a sudden you throw that out there, and I go, what? And I'm very used to using these programs, these flight trackers. I mean, we use them on a day-to-day basis. That's how I track my students to make sure they're where they're supposed to be at, sometimes. Because they track not just airlines. They'll track every small private aircraft.
Oh, yeah, I've seen them. Yeah, you can zoom in to any state, and you'll see every plane. Yeah.
Yeah, and they're accurate within 5 minutes. I'd say within 5 minutes, they are dead nuts accurate. I mean, you can rely on it. We use it on a day-to-day basis to operate our airport here. I mean, we have traffic coming and going. We want to know. We want to be ready for the aircraft when they land if they need services. So, so when you mentioned that, they don't track them over the ocean, I thought, what? Of course they do. I watch them track them all over. But sure enough, I did the research. I've watched the guys on YouTube, that said, no, I sat here for hours and they didn't fly across the ocean.
Yeah.
And I thought, no, I'm going to do it myself. Trust but verify. And sure enough, no, they don't. They do not track across the ocean.
Yeah.
That led me on a big, pursuit. I'm like one thing I said I'm still working on, still trying to determine what, how are they fudging the numbers? Because they are fudging the numbers. If you go and get the flight, the duration of the flight, it says it's going to take you 30 hours to get from A to B, but you do the math, it should only take you 15. So what's taking extra long? Well, if you measure that on the flat Earth map, you get a lot closer to the right answer. It's still not perfect, but then again, we don't have a perfect flat Earth map. So
yeah, an excellent point, because people have asked that. They keep bringing that up, and I'm going, look, at this point, the AE map, the azimuthal map, the continents may be laid out correctly, but now we don't know what the scale is.
Right.
It's like, okay, we there's nothing to say, 1 inch equals X number of miles. We don't have that, and nobody's ever mapped it.
And actually, so I thought about that for a little bit, and one of the things that I was trying to determine was, to determine the scale, if, obviously in the northern hemisphere, it has to be correct, because I fly from point A to point B, and if my map says it's 100 miles, I know my aircraft is traveling 100 miles per hour. I can do the math. I can do the time and distance. Forget the GPS. I'm not watching a purple line. I'm not relying on that. I can do the math, and I know it works out.
Yeah.
So, in my opinion, I think the northern hemisphere scale is correct.
Yeah.
Now, whether the southern hemisphere scale is correct, that could be totally off, because who flies down there? Nobody does.
Yeah.
And the only people that do, again, like you've mentioned, the airlines. I mean, there is private aircraft that fly in, South America and such, but not enough that I think anybody's going to be noticing. And I don't know anybody else that personally knows anyone who flies down there who can verify that, when they fly, it's,
someone with a private jet, some rich person or a drug lord can, going from southern hemisphere to southern hemisphere, maybe they might notice it, but, they're not going to care. They're not going to report anything.
And it, just like anything else, I mean, if you're, if you're, I don't know how this would be, but if you're on a ship out on the coast and you're going to sail from point A to point B, and, everybody kind of says, well, that should only take an hour, but, but the old timer says, no, it's going to take an hour and a half. Trust me, I've done it. I know it.
Yeah.
You just kind of say, well, hey, he's done it, he knows, and you just accept the fact that that's what it takes, because it does, and you don't question why. Your mind makes up these reasons. It fills in the blanks because it wants to rationalize.